To put it simply, a function is like a machine. Take for example the washing machine that you have. It washes clothes, it doesn't wash dishes. Though while you certainly could try, you would end up with some pretty bad results. This exhibits the first property of functions, that they only accept certain input. Type-specific languages may prevent you from trying to be funny and put your homework in the machine. But in non-type-specific languages, you as the programmer have to be careful that you don't accidentally put the compost heap into your washing machine. Now next, when we put stuff in a machine, we expect it to do something. If you have a washing machine, you expect it to wash clothes. If you put in a sock, you expect it to be returned as a clean sock. If you put in a shirt, you expect to be returned a clean shirt. Of course, you don't expect to put in your pants and be returned a watermelon. While you could make a machine for that, called the pants to watermelon machine, the washing machine will not do that, because it has been predetermined, coded to wash clothes. In computing and in mathematical terms, we'd say that for every given input, we expect a given output. This means every time I put in a sock, I expect to be given a clean sock back. Or I can put in a stuffed toy and get back a shrunken stuffed toy. Or if you insist, I put in the dishes and get a disaster each time. You might be familiar with the terms domain and image. Well, in this case, the domain is the input and the image is what you get out of it. Each domain can be mapped to one and only one image, though the converse isn't true. Putting in a watermelon or the dishes both result in catastrophe. Of course, it's a different kind of disaster, but that's why it's called an analogy. It's not supposed to work for every part of the comparison. Anyway, that's the second property of functions. There's a predetermined output for every input. The same input always gives you the same output. You can get the same output for different inputs, of course. So what's so great about functions then? Well, they allow you to condense code into smaller chunks that can be reused. For example, code that allows for the washing of stuff, they generally do the same thing, wash. Instead of writing the same chunk of code for different articles of clothing, let's create a function so that we can reuse the same chunk of code over and over again. This makes a lot of sense when you're writing large segments of code. Just as we use machines to simplify the otherwise repetitive and monotonous tasks of everyday life, we use functions in code too to make life better for everyone.